Welcome back. In our previous videos, we explored two fundamental concepts in queuing theory: arrival rate and service rate. These ideas help us understand how requests flow into and through a system. Today, we're diving into a new question: just how busy is the system at any given moment? This is where utilization comes in. Utilization is a key metric that tells us how much of the system's processing power is actually being used. By the end of this video, you'll know how to measure system busyness and why it matters for performance and reliability. Let's quickly recap the arrival rate, represented by the Greek letter lambda. Arrival rate measures how many requests enter the system every second. For example, if your website receives 50 hits per second, your arrival rate is 50. This metric is crucial because it sets the pace for how busy your system can become. Understanding arrival rate helps you anticipate demand and plan for scaling. It's the first piece of the puzzle when evaluating system utilization. Next, let's revisit the service rate, symbolized by mu. Service rate tells us the maximum number of requests the system can process each second. If your server can handle 100 requests per second, its service rate is 100. This metric defines the upper limit of your system's capacity. Comparing arrival rate and service rate is essential for understanding how close you are to maxing out your resources. It's the second critical factor in calculating utilization. Now let's answer the big question: how busy is the system? Utilization, represented by the Greek letter rho, gives us this answer. Utilization measures what percentage of the system's maximum processing capacity is currently being used. It's a simple but powerful concept that helps engineers keep systems running smoothly. By knowing utilization, you can spot when resources are idle or when you're close to overload. Utilization is calculated as the ratio of arrival rate to service rate. In other words, utilization equals arrival rate divided by service rate. For example, if your server can process 100 requests per second and 20 requests arrive each second, utilization is 20 divided by 100, or 20%. This formula gives you a clear, quantitative measure of how much of your system's capacity is being used at any moment. Look at a low utilization scenario. Suppose your server can handle 100 requests per second, but only 20 requests arrive each second. That's a utilization of 20%. In this case, the server has plenty of spare capacity. Many resources remain idle, which means you're paying for unused performance. While this setup is safe, it's not cost-efficient. Engineers often try to avoid running systems at such low utilization unless reliability is absolutely critical. Now, imagine 50 requests arrive per second and your server's capacity is 100. Utilization is 50%. The server is comfortably handling the load, and resources are being used efficiently. This is a good balance between cost and performance. You have enough spare capacity to absorb minor traffic spikes, but you're not wasting resources. Many production systems aim for this range to keep operations smooth and costs reasonable. Let's push utilization higher. If 80 requests arrive per second and your server can process 100, utilization is 80%. The server is busy but still has room for small traffic spikes. This is where many production systems operate, balancing performance and cost. However, as utilization rises, the risk of queuing and delays increases. Engineers monitor this closely to avoid sudden overloads. At 95 requests per second, utilization hits 95%. Now, there's very little spare capacity. Even a slow database query or a brief spike in traffic can cause new requests to wait in the queue. Latency starts to rise, and the risk of timeouts increases. This is a risky zone for production systems, and engineers try to avoid staying here for long periods. When arrival rate matches service rate, 100 requests per second with a capacity of 100, utilization reaches 100%. The server is fully occupied. If processing slows down or traffic increases, requests begin queuing, latency rises rapidly, and some requests may time out. This is why engineers rarely run production systems at full utilization. Keeping some spare capacity is crucial for reliability. Engineers rarely run production systems at 100% utilization. Keeping some spare capacity allows the system to absorb unexpected traffic spikes and temporary slowdowns. This practice ensures that the system remains reliable even when demand fluctuates. It's a balancing act between cost and performance, and it's one of the most important principles in system design. As a general guideline, utilization between 20% and 50% means higher cost but plenty of spare capacity. Between 60% and 80%, you achieve a good balance between cost and performance. Above 90%, the risk of queues and increased latency rises sharply. These guidelines help engineers decide how to configure systems for optimal reliability and efficiency. Utilization isn't just about technical limits, it's also about cost. Running at low utilization means paying for unused resources, while high utilization risks performance issues. The sweet spot is usually somewhere in the middle, where you get reliable performance without overspending. Engineers use utilization metrics to make smart decisions about scaling and budgeting. In real-world production systems, utilization is constantly monitored. Engineers use dashboards and alerts to track how busy servers are. When utilization creeps too high, they add capacity or optimize code. When it's too low, they may scale down to save money. This ongoing process keeps systems healthy and responsive to changing demands. Now that you understand utilization, you're ready for the next big concept, Little's Law. This equation is one of the most important tools in queuing theory. It connects arrival rate, service rate, and utilization to predict how many requests are in the system at any time. Stay tuned for the next video, where we'll break down Little's Law and show you how to use it in practice.